Food addiction can be as simple as enjoying a cup of coffee every morning to as detrimental as narcotic addiction. Due to the reason that eating is an essential activity for survival, bodily and psychological nourishment, coming up with an exact diagnosis of food addiction can be challenging and controversial. Let's look at the definition for addiction. It is a chronic relapsing disorder characterized by compulsive drug seeking, continued use despite harmful consequences, and long-lasting changes in the brain. We can mirror that definition to food addiction, which a chronic relapsing disorder characterized by compulsive food seeking, continued eating despite harmful consequences, and long-lasting changes in the brain. It shares a lot of similar features with binge eating disorder. The major symptom is the chronic compulsive overeating of highly palatable foods that trigger intense pleasure, which is also commonly related to obesity. Food addiction is also maladaptive, meaning although excessive eating might bring pleasure, people often end up feeling worse and guilty, resulting in a harmful circularity. Food like sweets, carbohydrates, fats, or a mixture of them are identified as potentially addictive, especially when we are not eating from hunger, but instead eating compulsively and losing control, even with acknowledged consequences. People characterized with food addiction are often misunderstood as lacking willpower, having a vacant mind. Have you ever thought that addictive behaviors are rooted in your genes? In this video, I'm going to show you genetic susceptibility to food addiction and how nutrition can help us improve and develop healthy eating habits. Genetic susceptibility, also called genetic predisposition, is recognized as increased likelihood or chance of developing a particular disease due to the presence of one or more gene mutations from family history that indicates an increased risk of the disease. Uncontrolled and addictive relationship with food, just like alcohol and other drugs, is initially driven by the rewarding system in the brain that controls and regulates our ability to feel pleasure, which, as a result, pleasure leads us to repetitive behaviors. Leptin is a hormone released from fat cells in adipose tissue. Leptin signals to the brain, in particular to an area called hypothalamus. Dopamine is a neurotransmitter made in the brain, which is released when your brain is expecting a reward. Genetic variation in the dopamine receptor gene, leptin receptor gene, suggests potential development of addictive behaviors on food, drugs, and alcohol. Consumption of sweet or fat food increases dopamine concentration, activates the reward circuits, and gives us pleasure response. TAC1A1 allele mutants located on the coding region of the D2 dopamine receptor gene were widely investigated. This allele carrier demonstrated reduced dopamine activity. Therefore, addictive activities are performed to compensate for insufficient dopamine activity. With regards to leptin, it works by triggering in the brain the satiety when we consume enough food and stop eating. Leptin receptor genes that have polymorphism are associated with levels of fat composition, energy metabolism, sweet preference, and obesity. Interaction of genetic variations between D2 dopamine receptor genes and the leptin receptor genes increase the likelihood of overeating and obesity. Various combinations of the defect gene develop cascade in the rewarding circuits into ripple effects, resulting in a rewarding deficiency syndrome that causes susceptible individuals to have the potential for unnatural addiction behaviors, especially to food. capacity to directly regulate metabolic processes through affecting the expression of enzymes, hormones, and other important biological molecules within our body, therefore our physiological states. When consuming increasing food intake, especially palatable, energy-high, nutrient-low food, an excessive amount of dopamine and leptin is secreted, whereas under normal eating, dopamine responses phase out after repeated exposure to a food. That happens more severely on susceptible individuals, since they need more food to get that dopamine level or leptin level up in order to feel happy or satiated. In order to overcome food addiction, avoid processed junk food like candy, sugary soda, high-fat fried food, or whatever junk food that individual is addicted to. Sometimes, entirely abstaining from certain trigger foods, particularly sugar or high fat or the combination of these two, is necessary. In addition, a low glycemic, anti-inflammatory diet can provide benefits in regulating reward behavior through central signaling pathways. After being exposed to these foods instead of highly addictive foods, the brain is capable to change and adapt, known as neuroplasticity. It is found that blueberry increases neuroplasticity as a supplement of a high-fat diet. Our brains are composed largely of fat, so they need support from a large quantity of healthy fats, such as omega-3 fatty acid that is found abundantly in cold water fish, seeds, and etc. In addition, a diet rich in polyphenol has been shown to enhance neural functions. You can find polyphenol in a variety of fruits, like apples, berries, and citrus, vegetables, teas, including cocoa. High-protein food also help increase the number of dopamine receptors in the brain and serve as the supply for two amino acids, tyrosine and phenylalanine, to make dopamine molecules. Introducing fresh fruits, vegetables, whole grains, beans, nuts, and seeds to the plate increases the consumption of tyrosine and phenylalanine. A genetic susceptibility to food does not mean that you are destined to overeating and obesity. Nutrition is one of the most powerful and effective ways to help you fight off the food addiction and develop a both physically and psychologically healthy relationship with food.